Okay, so welcome to today's panel discussion on trends in advanced analytics and data science. So today, we will focus on the tools and the practices that are recommended by industry experts in order to maximize the value on analytics and data science projects. So I'm Lishuai Jing. I'm a data scientist working with different business domains within GRUNDFOS, the largest pump manufacturer in the world. Before starting my data science journey, I have been doing research on statistical signal processing for wireless communication systems. So I'm really thrilled to host this panel discussion today because I simply like to learn from the best minds. So I even did some research on the origin of panel discussions. So according to the Harvard Business Review, it says that the panel discussion was invented by someone who liked to sit 3 feet above his audience, talk with 5 of his closest friends for an hour, and barely acknowledge that there are 100 other people in the room, usually sitting in very uncomfortable chairs. So what do data scientists love most? Innovation and make a difference. So today, we are actually making a difference on how panel discussion is organized. So you can sit anywhere that is the most comfortable to you, and we will not sit 3 feet above the audience. So what is even more amazing is that we are even not limited by the size and the ventilation of the room. And we can avoid the transcontinental travels in order to contribute to a greener environment. So now, let us give a very warm welcome to the panelists and get them self-introduced.
Sure, I can go first. Hi, this is Pragya here. I work as Chief Data Scientist with Hitachi Vantara Federal. It's a wholly owned subsidiary of Hitachi Vantara. Well, my data science journey started with my PhD at George Mason University. It was in computational sciences and informatics. And it just dawned the power of data-centric solutions on me. And this was while working on 2 very unrelated fields, machine learning of Galaxy's redshift estimation and United States federal accounting. Yeah, very different fields, but that's how I got introduced to the field. I have and I continue to work with various US federal government agencies to meet their very distinct business intelligence, data analytic, and data governance needs. I'm based in Washington, DC, and have a couple of hobbies in cooking, travel, etc. And I really look forward to this discussion here. Thank you.
Great.
I guess going clockwise. My name is Paul Kowalczyk, and I'm a senior data scientist with Solvay. Solvay is a specialty chemicals and polymer company. And my background, my degrees are in chemistry and in physical chemistry, and I started my career as a computational chemist, doing all things associated with computational chemistry within the pharmaceutical industry. Working for a few biotechs, I found myself putting one foot in front of another and migrating or moving towards doing a bit more with machine learning and data science, which is where I find myself today. Particularly, my wheelhouse, I guess, would be cheminformatics, which is what I particularly enjoy, both building models, deploying those, and sharing the information. My get-to here is that data science ought to build actionable insights. And so how one builds those insights, delivers them, and then communicates, has discussions around them is something I absolutely enjoy doing. And so that's why I'm a pretty happy data scientist. Thank you.
I guess I'll wrap things up. This is Dan Darnell. I'm on the product team at H2O.ai. I'm sure many of you know our products in the market. I've been in the ML space and analytics space now for about 20 years. The last 10 years spent in various companies building and deploying AI-based solutions for retail platform solutions, and now at H2O. So I'm pretty excited to be here. I'm not a data scientist, and I don't play one on TV or anywhere, but I'm happy to talk about trends and the things we're seeing in the market and the things I've learned from talking with our customers.
Great, awesome. Thank you very much. Just a quick check, and I got a question from some audience says that the video cannot be played. So if there are some other people have the same issue, please leave your questions there so that we can check on our end to see what is going on there. So thanks very much for the introduction from the panelist. I think that is, as you can see, we have a very experienced and very diverse panelist today, and that's really a fortune to us. So now let's jump right into some of the questions we have in mind. So the first question comes as when I started my career as a data scientist 3 years ago. So data science really has an amazing future. So data scientist has been claimed to be the sexiest job in the 21st century. And in these years, we also heard the stories that data scientists start to quit their jobs due to the misalignment between reality and expectation. So how does the perception and adoption of data science change in the past few years within your organization or industry?
Sure. Okay, I'll go ahead. So yes, it has changed a lot, definitely. Initially, data would not be seen as an asset. It was seen more as a byproduct of a software solution in place. The power of data-centric solutions were not immediately apparent, let's say, about 10 years back, 10, 15 years back. But it has changed drastically over the past few years. We see, particularly in the federal government space where I'm closely associated, we see a lot more interest, a lot more curiosity as to how data science can help them. There's more eagerness to try out new things and change their processes to be able to accommodate the distinct way in which a data science project has to be addressed compared to a software development process. So I do see a lot more interest in data science compared to a couple of years back.
One of the differences, perhaps, that I see in data science now is becoming a bit more formal, if you will. So clearly I'm a little bit longer in the tooth. And when I first started doing a lot of this, some of the same processes or the workflows I was building, say, a decade ago, I still use today or employ today. And they weren't called data science back then, but they are called data science today. So a lot of my colleagues grew up in that same milieu. And so to what Pragyan said, our backgrounds aren't in data science. Many may not have had particularly formal training in data science. When we started doing this sort of thing, there were no data science programs. There were no, there weren't YouTube videos that showed you how to build a machine learning model. So it's a bit different. And so I think there's a cadre of people today who are calling themselves data scientists and are, but come from other fields. Astrophysics. One of my colleagues at Solvay was an astrophysicist. Others come from theoretical physics, theoretical chemistry, where they've done an awful lot of number crunching. And so now they're doing it in a different environment. They're still number crunching, but instead of being redshifts, it might be a financial table. And so they're just going forward. So the shift I see those now today, there are opportunities to be trained in the entire workflow, if you will, of a machine learning or a data science campaign.
Yeah, and really from the perspective of the technology platforms, there's been a huge shift, obviously, in the last few years, where I would say a couple big trends. One is we just automated a bunch of the routine processes that people were doing in notebooks even just a couple of years ago. And we've automated a lot of that stuff. Things like feature engineering and other things can be fully automated in a lot of cases. So that's changed the kind of ability of people to deliver projects, which actually kind of pushed things over to the operations side, where people said, how do we get these things into production? And I think a lot of projects failed, honestly, because there was no strategy for how to put them in production. So there's a lot of disillusionment a few years ago. People working really hard, hand coding in testing, experimenting, building a really great model that didn't make it into production or never got used. And so there was some disillusionment there. And I think now, just as an industry overall, we're trying to fix a lot of those issues.
Yes, I think that resonate quite some of the similar situations in different places. And one of the interesting is that data science as a function it is growing more and more mature. And how does the data science team or lab anchored in your organization, and how do they actually interact with different business domains to ensure that so that they can get the analytics projects into production?
So I guess I can start. My experiences have been that data science acts as something of a wheel and hub, where there are spokes coming out of the hub, and the data science teams I've been a part of are in the hub. So we're not necessarily assigned to different business units or different pieces within the organization, but rather we're available to everyone. I think there's an advantage there, because in as much as we're transversal, we get to see a lot of what people are doing. In many instances, activities in one area translate well to another. So we almost become bridges between different business units because of the requests that they make. So my experience has been that we communicate with our colleagues, but we do that across the organization rather than within a particular pillar within the organization.
Okay, I can go next. So I would say in our case, it's usually about since I work with various different agencies who have their very own specific missions and goals, and it can vary than the type of data that they handle with. So the first step that we take with them when we are working with a particular agency is that help them define the why. What is the benefit they're expecting from their data science efforts? And doing that via design thinking or continuous iterative discussions with them, as well as using various visualization techniques to be able to do exploratory analysis of the existing data and suggest improvements. And so that's the way we navigate through the domain as data scientists, working with them to get a better understanding of their mission, better understanding of their why, and helping them make the max of the data science tools and techniques to reach and accomplish their goals.
Yeah, that sounds really interesting. I think sometimes when we start a project, now I'm going to loop a question actually from the audience. I think it's very, very, very related. So it's like when you start a project, right? Then who are the stakeholders you approach within an organization, and how do you actually get your projects?
Sure. I can go first if that's okay. So yeah, typically in the federal government space, there's a very formalized process where there's a request for proposal, and then they identify the stakeholders, and based on their needs, we go back to them and tell them that, hey, if you're working with this particular technology as a data source, or with this particular framework that you have in place, which is going to be a data source, we need stakeholders identified from those specific technologies so we can work with them in getting into the nitty-gritty details of the data ingestion process, and what are you, again going back to my earlier response of why are you actually doing this, what are you trying to accomplish out of this, and helping formulate that. So that's typically the way we go about it. At times we have heard about a specific need, we approach them and let them know that we can do this quick proof of concept and help you get a good understanding of it. So those are primarily the two ways in which we pursue a project.
Some of the projects that I work on are trickle down, so management presents them, and there's some sense to that, because if a company recognizes the need for a data science group, hopefully it's because they have some projects that they think the data science group is going to address, and so once the group's there, they start. What I find, though, is that once you start to build relationships with colleagues within the company, they start coming forward with problems or questions, and so then it starts to become a self-fulfilling prophecy that because you've worked on a project with a particular set of colleagues, they'll come to you with the next project, that sort of thing. And we'll have this moment, and then what Pragyan hit on, I think, is absolutely critical to the success of a data science group or to analytics in general, is never lose sight of the why. I know there are instances where I'll build a model and we'll be excited because it's efficient. It's golf code. I didn't have to use too many lines. I got it to work really quickly. I can productionize it. But what's important is at the end of the day, someone has to want to use it. And so staying true to the driver, the request, the stakeholder's request is, I think, the shortest path to success. Thanks.
Yeah, we see that in the sense that what customers are asking for is the ability to do kind of rapid prototyping. A lot of times it's the ability to get something in front of a domain expert, really their business client within the business, so those two can work more closely together. That's really something that's changed recently, I think, in the technology space, that now there's a desire to kind of be able to interact and create, for example, applications that the domain expert could interact with the data science work, right? That way there can be a two-way exchange between those people, instead of project gets created, goes off into data science land, gets built, and then maybe people lose sight of exactly why they were doing that. And when it does eventually come back, it misses the mark, which I think is what we're all trying to avoid.
Yeah, it's great to see so many diversity ways of doing this. But when it comes to the practical projects and what kind of tools and the technology stacks are used in your company for data scientists to do their daily job, for example, it could be communicated with different stakeholders, or it could be when they do data engineering, training models, or deploy solutions. And what are the typical tools they use?
You want to go first, Paul, or Dan?
Anyone will.
You went mute.
Paul, I think you are muted.
My apologies. We've got forced air control on, keep the noise down. When we're prototyping, when we're first starting out, it's usually notebooks, so R and Python, and those are very local solutions. So we'll start there, show the prototypes to our colleagues, to the subject matter experts, to the stakeholders, and if it resonates, then we'll work to bring those into production. And then we have data engineers and others within an IT group that can then write the APIs and the wrappers that are necessary. So essentially somebody accesses the tool via a URL. But our workhorses at this point are Python and R.
Mm-hmm. Great.
Yeah, in our case, we typically start off with, of course, understanding what the problem is, and first identifying if our products make sense to be used there. And since we have multiple products, some very specific to structured data, some very specific to unstructured data. So understanding the data is prime in our case before we even come up with architecture for the same. And then looking at these other different tools, open source or other third-party tools, which we can orchestrate and come up with a seamless way of data transformation, feature engineering, and leading on to more advanced analytics of machine learning and machine intelligence type stuff. And it could be something like H2O.ai, or it could be any other tools which are available in the market for which address those specific needs.
Yeah, I think we see one trend I've noticed is since tools like AutoML, like a driverless AI, things like that have been introduced, we'll talk with data science teams that, once they really understand what that product is good for, they will start using that because they realize it will free them up. If it's a classification or regression type of problem and they recognize it for what it is, they can say, oh, this product is really, really good at that. Or if it's image classification or any of the other types of data science projects that those tools are now capable of, they'll realize that there are projects where their real skill in customizing the data science is needed, and they'll spend their time on those, and they'll use an automated machine learning product to drive some of the other projects that they might have tried to hand build before.
Mm-hmm. Great. I think following the thoughts of the tools, some of the tools, for example, auto ML or DataOps and MLOps actually becomes very trendy these days in data science community. So let's first take the DataOps. And what is your take on DataOps ops, or in general, how do you actually keep the data quality and the integrity to a very high standard, so that the analytic team can use the quality of the data so that they can build good models?
Sure. Yeah, like we, the company itself, like we treat data ops as like a very critical component of the whole end-to-end data analytics piece. It is, we know that data is constantly changing. There are new tools and new technologies which are coming up, as well as the people associated with a given data project can change. So keeping in sync the people, process, and technologies is the strength of DataOps provided to a data science project. So it's very critical for us at looking at like different parts of the end-to-end data analytics, starting with a data catalog, so that you are able to identify the data sets that are relevant to the work or the specific problem you're trying to address. And then looking at the other tools which let you do feature engineering, data mashup, and moving on to the next components of doing advanced analytics or even business intelligence and business analytics. So that streamline and continuous and iterative process is enabled by DataOps, and we truly are pushing on that as part of our various projects.
For us, it's no data science. And so the integrity of the data is absolutely critical to any process. Given the background, the field that we work in, there's often replicate data available. So if the question is to data integrity, usually results do have a standard deviation and error bar built around them, and we use that when we build our various models. It's really, what's been said, it's data accessibility and then the veracity of the data that we can go after. And that's an instance where it's always been my experience that I really do count on my colleagues that the data that they enter, the data that I have available, is as good as the data that could be available, if that makes any sense. I'm saying that internally to the companies, you do have those single points of truth. And so then you can build your models off of that base.
Yeah, I think as I think of this question, I have pretty significant background in the ML ops, model ops space. And I think one of the big things that's really come to the fore in the last few years is understanding that you're going to need production data, not just training data for a model in a data science environment. But once we bring that over into production, we're going to need to, best practice, for example, would be to retrain that model on big data, not small data from a lab, but retrain that model and make sure that it fits on the production data. And so when you start to look at these kind of production data issues, you get a whole new set of criteria. And then you realize you're going to need a whole data pipeline on the production side. It's got to be reliable. It's got to be scalable to feed your production model. And so just a whole host of data ops issues that are really, really important for productionizing models for sure.
And if I can end with like one quote which I could remember and which I recently came across is bad data is worse than no data. So that just tells you how important data ops is in the entire process cycle.
Yes. Are there any tools you guys use in order to to enforce this practice? Or has it been discussed on a company level or team level so that they can coordinate on the effort to make sure that people are understanding why this is important and how to give a priority on this even before doing some models, for example?
I think there has been an organic understanding of the criticality of data quality. The tools that primarily we recommend in the DataOps cycle is the data lineage, and which enables your data provenance, getting a good understanding of where the data originated from, what were the transformations that happened in the data, and what is the point in the data transformation cycle that I am getting this data from, and what are the modifications I'm making, and am I getting that documented as well? And making that more transparent to the whole process cycle is something that is most encouraged. If something has to be done manually, there's always the human error which creeps in. So trying to automate as much as possible of this data provenance effort is important.
What we find particularly effective is also to have tools that, I guess, lowercase p, productionize data curation. So as data starts to flow through, what we try to do is make sure that any data curation is itself reproducible. Some of them are easy things. If something's being reported as a percentage, it can't be less than 0 or more than 100. So you codify that. In some other instances, you might have some subject matter specific criteria that, again, you would codify. So as new data comes in, at least you can flag it that way. And what's nice about having the code is, instead of looking maybe necessarily at volumes of data, you can look at just some of what you are filtering or curating and say that makes sense. And knowing that if you put your raw data through these processes, on the other side, you have data that's ready for modeling.
Yeah, and a lot of what we're looking at in this space, we're obviously not on the data management. We're sitting on top of the data management frameworks, but we're trying to automate as much of the data processes as possible on the front end of that modeling process. So as we augment data, as we prep data, we're trying to learn from the preparations that are happening and continue to automate as much of that as possible, so that what goes into the model is as high a quality as it can be. And also, once we've prepped that data, we want to capture what we did so that we can go in the production process and apply that same logic and have that same intelligence there.
That sounds great. I think automation seems is very critical here, in order to make sure that the human errors don't suddenly pop up. That's really good. And then for the ML ops. So what are your thoughts on that?
I can start there. It's an emerging field. I don't want anybody to feel like they're behind. It's something that, having been in that field for the past few years directly, I can say that a lot of big companies are now realizing that they're not going to be able to scale, especially with their adoption of a lot of variety of frameworks coming out of open source. They're not on one platform anymore, right? They're not using a single platform. There's a variety of techniques they're using coming out of a variety of different places. And to get all that stuff into production, there's a huge challenge, right? You can't go to your IT team and say, can you put this Python model into production? They will go, we don't know what Python is. We don't trust this. And there's this mission critical nature of production models that will just prevent them from doing anything. So MLOps really comes out of that need to create those production pipelines. And it's a set of tools that, some bigger companies have built their own. And there are a number of open source frameworks you can build on top of. And now you're seeing vendors who are coming out with MLOps products, which, in my experience, primarily help you deploy on top of Kubernetes, typically, because that's been the primary framework. They help you monitor. So they have features like the ability to do drift detection on top of your data to see if your model has drifted. They help with lifecycle management. So you're going to have to replace that model if it does drift, or whenever you want to update it, you're going to have to replace it. And then they should also provide some governance to ensure that the right people have access and that you're tracking and tracing all the things you would need for that production project. And I think those products are coming along nicely in the market, but it's still an emerging space.
Yeah, so in our product, which where we do data ingestion and feature engineering, we do have components which enable us to do model evaluation and selection, as well as parameter tuning, and then as well being able to, once you have a productionized model, also like being able to, as was already mentioned, like evaluate, compare, rebuild, and monitor those models on a continuing basis to determine the drift, and also also being able to do various different algorithms evaluation and figuring out which algorithm makes most sense for this problem, which has the most accuracy. So having all that as part of your data ingestion pipeline becomes critical as more and more people are interested in using machine learning as part of the data ingestion process, not just as an endpoint of machine learning pipelines.
Great. I think this the ML opt is a very good concept, and there's also very challenging to find out who does who in this concept. For example, you have a data scientist, and you have the business people, and you have an analyst, and in your experience, how does it operate in practice? Who takes care of the pipeline, and who takes the model, and who takes care of the monitoring, and the whole cycle. As a business owner, what do they do?
Yeah, typically a team should, like ideal world, a team should have a data scientist as well as a machine learning engineer. The way I look at it is like the data scientist is the one who tries out multiple things, zeroes in on a couple of solutions, and then the machine learning engineer is the one who goes in and just makes it more robust and makes it working with the entire framework that you have in a given application or in a given organization. But often we see like there is a interplay, like you will see even like data engineers doing some part of data science and data scientists doing some part of data engineering, that creep over or fuzzy boundary exists even today. There's no clear demarcation there. So that's typically how we have been functioning, actually.
As a, I guess as a data scientist, I'd always argue for the primacy of a data scientist in a team. So now people can throw spears and arrows. But I think there's a reason that in building products, I think it has to be function first and suave second. So the first thing you want to do is deliver a model that is good, that if it's classification, classifies with the fewest number of errors. And then again, you can even adjust the model to have fewer false positives or fewer false negatives. And if it's regression, is it important to get the number spot on, or what have you? And so that's why I think it's important that before you even start considering taking things into sort of a pipeline, that you scientifically the model is sound. That being said, then it can go into all of the rest of the ecosystem, the rest of the universe, and productionizing and having people using it. And I please, I do not mean this pejoratively, putting the proper bells and whistles on it so that in fact the aperiodic user can come back to the model, still know how to navigate and employ the model to purpose.
Yeah, I think in the world we would like to see in MLOps, there would be really operators in the IT department who could run these models and who could operate them on a day-to-day basis, even doing refitting and other capabilities, the things that we're building into our products. But that's not yet happening, right? I don't think we have an MLOps team yet in the IT side. I think it will happen. I think there will be, just like we had DevOps pop up and we realized we needed to do CI/CD on software applications. We're going to have an MLOps team, and that MLOps team is going to do the CI/CD operations, monitoring, and the management of these applications. They're AI applications running in production. What I see today, honestly, is a lot of data science involvement in that process. But what I hear is that a lot of those data scientists would like to do less of that and more of data science. So I think it's a win-win. The data scientists would love to have a very competent, capable team over in IT who could help manage things, so that they could be doing more projects, and that's obviously what the business would like as well.
Great. So I think this is one of the key issues that many companies are considering, and and it will evolve, as time goes by. I think the next question I'm going to switch a little bit to the auto ML. I think there's a question coming from a customer. I will just try to summarize it in a way that it becomes more general. So auto ML is great, and it has been people have been trying to use that in the industry for some time. And there's still one key question is that one part is make your data ready to do auto ML, and the other part is what if auto ML does wrong? Who should we blame? Is it the auto ML tools, or is it something else?
Sure. So machine learning itself is like a machine that can learn from experience, from the training data we provide. So providing the data to be used as part of your auto ML process, it's serious business. It's not that you can just throw any data into it and it should work. It's the whole cliche statement of garbage in, garbage out would happen there. Who would be held responsible? I think it should be, if enough effort is put into the processes involved in the DataOps process that underlies the auto ML process, a good part of those problems would be addressed. Otherwise, it's as you're going through the effort, learning from it, and I'm sure Dan can speak more to the whole explainable AI piece, which is a key focus of H2O.ai, as well as a couple of other organizations. Having simple models, having models that are explainable, that's equally important. And that also takes care of some of the problems of not being able to understand the complexity and having certain biases and unexplained behavior, which causes unintended consequences from a machine learning model that is put into production, for example.
Yeah, I was going to say that what we saw and why we invested so much in the machine learning interpretability, the explainability portion within driverless AI, is that people needed to have confidence in what they were building. And data scientists use driverless AI, and then it gives them the transparency so they can go see what happened. Hey, this was the best model, or this was the ensemble that we built. Why did we do that? What did we pick and how did we do it? Try and make as much of that data available as possible. So I think what I hope people don't think is that auto ML should be a black box that just does a bunch of stuff and spits out a model on the other end. It should be an open process where you can go in, influence that process, customize that process, and ultimately come out with a model that you understand what it's doing.
I'd echo that. I think what I would hope people would come to understand is that machine learning guides, but humans decide. So the decision might be, I'm just going to use the model just as it comes out, and I'm not going to change anything. If it says yes, I will say yes. But I think what you're saying now is more and more looking to interpretability. It's not that the R squared is 0.87, but why? What were the important variables, and how, and what's true of that? So it's the whole, it is, and then what Pragyan said is that it's all about the data that's ingested to build the model. And so as new data becomes available, I think it's incumbent upon data scientists to rebuild the models. And it could very well be that a different algorithm, a different set of features is better as more data becomes available. So it is a process. It's not just a destination. And if people are happy with that, or if they embrace that, actually, I think that it's used best for all parties concerned.
Yes. So I think transparency and the control to the people who are using it is quite critical here. But when we, for example, have so many good tools at our hands, and then in practice there are other challenges. For example, to make AI solutions scalable. So typically we will face the scenarios like a scale to different customers, scale to different countries, scale to different product categories. And do you have some kind of practical examples on scaling AI solutions that you can share with us?
Sure. Let me start with an application of AI that we have in our data cataloging tool, which is part of the whole DataOps process. It's the first step of identifying your data set. But as you have data assets available in an organization, it's in large scale. It's no longer like one simple file or one simple CSV file that we are going to run through our machine learning process. It's in petabyte scale, sometimes in terabyte scale, and these data attributes and data structure changes in the different databases or the various other type of data assets you may have. Now, being able to manually go in and define each and every attribute and have a good understanding of that is maybe possible, but maybe not. It's literally humanly impossible if you're particularly trying to take advantage of that data asset in a timely manner. So we have an AI process in the background which characterizes each attribute by 100 features, 100 plus features, and then uses that to suggest tags for columns which it sees in new data. And of course, there's a mechanism in place where a human user can go in and say, yes, this is correct tagging or not. So that is one of the ways in which we are using AI to make the process of data quality and data curation more feasible than possible before just doing it in a human-centric way, just having a human user go in and do the same.
I can comment on scale. I mean, I think a lot of people who know H2O know that we've scaled out. You know, we were some of the first, big data algorithms and whatnot. So I think we obviously see that a lot in our customers, just scaling out machine learning at a pretty massive scale. I think in terms of adoption, though, I would say the more interesting trend is building AI into applications. So we, and in that case, you're getting AI into the hands, or your model is getting into, and models multiple are getting into the hands of many users. Just as an example, one of our customers is a large accounting firm, and we worked with them to build several applications which are used by their auditing teams. And now those auditing teams are using AI every day with all of their customers, because it was built into an application that those people could use. It was designed and built for those users to use every day. So I think there's scale out, and then there's how do you make it actually usable by real people that gets it used and scaled out. And that's more than 100,000 people are using that app.
Mm-hmm. It sounds very impressive. So I think the tools and the technologies comes rather fast and very frequent in the data science field. So for enterprises or data scientists, typically it can be very challenging to stay current and manage the complexity of these tool chains. And on top of that, they may have built solutions and algorithms, etc. Based on some technologies that exist in the past. So how do they manage this kind of complexities in real life?
Have multiple TBD lists of learning. I'm pretty sure each of us has a notebook or a paper lying around somewhere with, this is interesting, I should pick this up. Yeah, it's an evolving field. It's not a mature field. It's growing. There's lots to learn. There's always new techniques, new approaches, new methodologies coming into the field. There's constant learning involved. But being able to define your swim lane and prioritize those learning goals is important. So I may have 10 things that I want to learn next, but being able to prioritize those 10 based on what is most critical for me at this moment, or I need it definitely in my upcoming projects, or what would add that extra element in my arsenal of tools that I don't have familiarity with yet. That's part of the learning strategy.
I find that trying to stay current can be a lot like that game Whack-A-Mole. you know, right? Where you knock down one mole and another one pops up somewhere, and then you go after that one and another one pops up. I'd read just recently that a suggestion was, instead of knowing everything, perhaps know a few algorithms well, so that you could teach or describe them to someone else, and allow that. Hopefully, we're all part of data science teams, and so that our strengths might be someone else's new learnings, and things that we need to learn might be someone else's strengths. So hopefully, as a team, we can deliver products that help our various organizations. It's not necessary that as individuals, we deliver all that entire ecosystem of results. But to that point, I remember going back a bit, I like to say, you ought practice like you'll play. So I've always said, these are languages, and you don't learn a language by reading a book, closing it, you know, like every Saturday, taking 2 hours to learn a little bit and then wait until the next time. You need to put these things into practice. So if you see something that's interesting, try it with some of your data, and until it works, and then just store that away. But it's always, to read it isn't to know it. To code it up with your data gets you a little bit closer, and at least that helps me stay current.
Yeah, I think one of the things we do is try and put some of our experts out there. We've been hosting a number of panels and other things just to try and get. We have a number of Kaggle grandmasters who are on our team, and we've been doing a bunch of panels, but primarily for educational purposes. You know, what are they seeing? What are they doing? How would they solve certain problems? Things like that, just to try and make as much of their expertise available, especially around COVID-19, as people have been trying to solve problems there with small data and other things, just trying to make that resource and their skill set, you know, make as much of their knowledge as we can available.
Do you have some specific sources where to keep you up to date, or reading papers or conferences, or, you know, some other, you know, what kind of channels do you use, you know, in order to do that?
Yeah, archive.org is something that I commonly look up for the latest papers and what are the researchers working on, as well as I find the tech Twitter folks very willing to share and help out. Sometimes even like I've seen people ask their coding questions and people help them out. So that's a very good forum. Find the right data scientists, data practitioners, and follow them. Get involved in the various discussions which happen, as well as the various MOOCs, such as Coursera, Udemy, and I do run a meetup here, and we often pick up a particular course from Udemy and then try to cover it together as a team, which is a good effort in terms of keeping each of us accountable and so complete the course instead of just signing up for the course.
Great. So since we are talking about the COVID-19 times, has there any shift in priorities or project, you know, because of this in your daily work or from the company focus point of view?
I can comment on what I'm seeing from our conversations with customers. I think what shifted primarily was all the old models broke. When you look at, you know, banking, healthcare, so a lot of data scientists were, you know, and companies were coming to us saying, "Can you help us build new models quickly?" Which obviously we have the technology to do that, but also are there other techniques and things that we could be using that would work on smaller data sets? So that was one of the challenges is really incorporating new data and deciding whether you can simply incorporate those new data elements into an existing model to improve its accuracy in this new day and age, or do you need to entirely scrap what you were doing and start over? So there was definitely a rush around, you know, figuring out what to do and building some new models for sure. And one of the things that changed pretty dramatically for us was that people needed that insight to be actionable right away. So we built some apps for a large healthcare provider to show them where they should be putting their resources in hospitals. Where are you going to need ventilators? Where are you going to need your nursing staff to be located in the coming week, in the 2 weeks? So they needed predictions to do that. And it wasn't going to be sufficient for us just to build a model and hand it to them. We would need to build an actual application that they could interact with. And so we went ahead and did that. And we've been building a bunch of different apps for mortgage lending and other things as well to help customers. So that's been a kind of a shift, I would say, from us working with customers just to build models to actually building end user applications that they can interact with.
Yeah, I think for us, along those lines, actually, as part of the whole COVID and the way in which the importance of data quality and data curation, I don't think it was as apparent before as it is right now, where we continuously see research results being provided and then being retracted because the data quality was not good itself, based on which those findings were published. So it becomes even more important to have your data curated in the right way, and the data provenance and the data lineage becomes even more critical to the process. As Paul was saying, like, the journey is even more important than maybe the end process, end state. So that has definitely dawned, and it's like super critical.
One other thing that I'd say changed with us was we saw tremendous interest in external data sources. So because people didn't have data internally, they said, what can we do with other data? And I think there's actually been a big shift in the data market, if you will. People finally realizing, there's going to be an opportunity to create subscriptions or sell data and or make data available to other people because they just don't have the data, right? And that's also opened people's minds to, maybe we don't have all the data that we would need to react to a given situation. Maybe we should think about partnering or subscribing or using data from other sources. And we've incorporated a bunch of public data, for example, into what we're providing to customers. And we're working with a number of other data providers right now. So I think that emphasis on not just my own data, but getting access to other data has been an interesting development.
Yes, I think this is it will do good to the common data science community in order to leverage different types of data. So there's now I'm going to jump with one audience question here. So can you share other use cases and industries that are trending at the moment? I guess this could be linked to the question that are there any other emerging trends in data science community that worth paying attention to in the short term and the long term, and what tools and technology do you wish to have in order to actually accelerate the data science value creation process?
Talking of industries, I don't think there is any industry remaining which has not been touched by data science, or where they're not seeing the need for data-centric based solutions. I'll say, okay, let me focus on the governance, the federal government itself. Like, they have a couple of acts formulated now where they're trying to do policy making based on data, instead of the earlier ways in which it was not as data centric. I'm pretty sure they were using data, but making it more data focused is a push that we have seen over the past few years. And there is a foundation of evidence-based policy making in the US federal government, which is being pushed to make the policies based on data, and making the data also accessible to the citizens. Open data. And as the name says, open means data is openly accessible via, there's a website called data.gov, as well as making the data accessible in a format which can be automated in a downstream data analytics, a machine learning process, whatever you need to do to make it automated. So that's, I would say, is a very significant improvement. There have been a couple of other similar acts which focus on subdomains like grants, the various grants which are given out by the federal government, keeping track of those and doing analytics on the same. There's a great act, that's the term which is used for that. And apart from the federal government, I've seen like the manufacturing, the rail industry, health sector, you name it. They literally everybody is using it right now.
I was just going to comment on manufacturing has really come back, I think, in a big way, especially as people try and figure out like now what to manufacture. We have one CPG client who we worked with to kind of reevaluate their supply models for resupplying their distribution chain around COVID-19. And that was really, really fascinating because it's like they've got to figure out everything all the way back to kind of what products to buy and bring into their manufacturing facilities and what to make and where to send it. I mean, this is a really interesting problem that, you know, before they had well-established models, they knew exactly what they were sending, how much they were replenishing. And now they've recognized that data science, they're going to need data science to refresh these models because that could actually now be changing on a fairly regular basis. This isn't something that's just going to be consistent over time like it used to be.
Your trading data has become your animal era.
Great. I think we are running out of time now. I think we have last few minutes. Then I will take one of the questions from the audience, and let's take that one as the last one to end up the talk today. So the question is on the business governance model. How can we leverage that in order to work towards a successful development, such as maybe in place for large companies to get life cycles of business application automation? So basically, you know, how do they do that? How do they, you know, governance the whole process to make sure that the solution can operate while in production, and on top of that, they can do all the retraining or maintenance on the model as well?
Yeah, short answer, MLOps.
Sorry.
That's one area. I mean, I think governance, look, we've all had to deal with governance over the years. It's not a new topic within companies. Data governance is there. You have governance teams. I do think there's a new area of model governance, production model governance, but I think the characteristics are very similar, right? We need to make sure that that we have the controls in place. Depending on our industry, those can be varied, but I'd say access control, like who can go touch things, is really, really important in production, especially. And do you have the kind of traceability and tracking that you would expect so that you can go back and not only troubleshoot as a data scientist, but you can do any legal or regulatory compliance that you need. So having the metadata, you should always be focused on, you know, where's the metadata around my model in production, and do we have that stored and is accessible? And you have, you know, we talked about it before, do you have a full version history and repository of all the models that have been run? Has that been stored? So I think from a data science perspective, making sure you have those things in place will help ensure that you have a solid governance strategy. And then as a company, you should be looking at, you know, do we have a governance plan for these models? I would say it's the first thing you should think of in your production process.
Mm-hmm. Great. So I think that's all for the question for today. I think it's really a pleasure to talk to so many experts in one time, and I definitely learned a ton. So I hope the audience also enjoyed the talk. And if you have further questions, I think you all have ours in LinkedIn, etc. So please reach out. And I think being in the data science community, helping each other is also one of the key things we would like to do. So with that, I would thank you very much for the panelists and all the audience online who have the patience to live with us. And thank you very much for today.
Thank you. Thank you, everyone. It's a pleasure.
Thank you.